So if two events A and B are independent, and we said yesterday that meant one event does not affect the other, then the probability of both events occurring is the probability of A times the probability of B. So probability of A times the probability of B. One thing that you'll hear me say a lot starting tomorrow is if the problem says the word and, then you multiply. So go ahead and write that down. If the problem is asking what is the probability that you're on time on Monday and on Tuesday, then you would multiply to get your answer. Okay, so at a picnic, Julio reaches into an ice-filled cooler containing 8 regular soft drinks and 5 diet soft drinks. He removes the can, then decides he is not really thirsty and puts it back. Find the probability that Julio and the next person to reach into the cooler get. So this is what's important right here. He puts it back. Underline that for me. He puts it back. Okay? So he picks a can and then he puts it back before the next person goes. So we're not going to do this. We'll go ahead and jump right here. This means what is the probability? What is the probability that he gets a regular and a regular? That's what that means. So the comma means and. Okay? All right. So let's start with the total on the bottom. How many total soft drinks are there? 13. Right here. 8 plus 5. 13. So there's 13. And how many regular are there to pick from? 8. Okay. Thank you. All right. And then when it says the word and, we're going to multiply. When it says the word and, we're going to multiply. Okay. Now, he put the soft drink back, so there's still going to be the same probability for this. There's still 13 cans in the cooler. And how many are regular? 8. So it's the same thing. So in your calculator, remember to use parentheses for fractions. What's another way you could type in 8 over 13 times 8 over 13? Yep, and I think that's quicker, but again, it's totally up to you. And let's go ahead and make that a percent. Yes, sir. Thank you. Okay. All right. This next one means the probability of a diet and a regular. A diet and a regular. So, Jasmine, what would be my fraction to get a diet? Good. 5 over 13. There's 5 diet in the cooler, and there's 13 total. Denise, what does and mean to do? Multiply. Carter, what would be my fraction for a regular? Good. 8 over 13. And anybody can give me the answer? Okay. All right, and this last one is the probability of a diet and then a diet. So, Ethan H., what's the probability of getting a diet the first time? Good. Autumn, what does and mean to do? Multiply. And Cole, what's the probability of getting a diet the next time? 5. Yep. And anybody? 14.8. Okay. All right. B, in a board game, 3 dice are rolled to determine the number of moves for the players. Find the probability of each given situation. What do you think this means right here? The number that you roll. So what's the probability of rolling a 6 and then a 6 and then a 5? Okay, so let's always start with the total. I think that's easier. How many total sides are there to a dice? 6. Okay, so 6 goes on the bottom. Now, I'm trying to roll a 6. How many sides are there to give me a 6? Just 1. There's 1 side to the dice that has 6 dots on it. So 1 over 6. Then I'm going to multiply. And again, what's the probability of rolling a 6? 1 over 6. And then what's the probability of rolling a 5? 1 out of 6, because there's one side that has 5 dots out of a total of 6 sides, okay? Once again, what's the shortcut to typing that one in your calculator? 1 over 6 to the 3rd power would be the shortcut. You're welcome to do it the long way. 0.5%. Okay. All right, let's jump down to 2 underneath it. Probability of rolling a 4, and then rolling a 4, and then not a 4. Rudy, what's the probability of rolling a 4? Yep, 1 out of 6. AJ, what's the probability of rolling a 4 the next time? 1 out of 6. And Sterling, got to use your thinking cap here. What's the probability of not getting a 4? 5 out of 6. There's 5 sides that are not 4. There's 5 sides that are not 4. Anybody? Okay. All right. Austin C. What is the probability of not getting a 3 on your first roll? 5 out of 6. Good. And we are multiplying today. Ashley, what's the probability of not getting a 3 on your second roll? How many sides are not a 3? There you go. And Dan, what's the probability of not getting a 3 on the third one? That's fine. What's the probability of not getting a 3 on a dice? 5 out of 6. Okay. Anybody? Okay. All right, this last one down here, probability of getting a 5, then a 6, then a 7. What? 0. Why is it 0? You can't get a 7. Next one, probability of getting 3 5s. Jonathan, tell me about this one. Probability of getting 3 5s. Bottom number 6. So on the first roll, how do I get a 5? 1 out of 6. Then on my second roll, how do I get a 5? 1 out of 6. And on my third roll, how do I get a 5? 1 out of 6. Okay. Once again, that one's going to be the same as that one, so it's 0.5%. Okay. All right, guys, what's the probability of getting any number? 6 out of 6, which is 1. So you could write it either way. I don't care. Okay. Again, probability of getting any number, 6 out of 6. And let me call on somebody for this one. Eden, probability of getting not a 2. 5 out of 6. Do you have to type 6 over 6 in your calculator? No. Okay. All right, what you got for this one? Okay. All right. This next one, probability of getting a 1, a 2, a 3, and a 4. Or not a 4. What? 0. Why? Yes, you only have 3 dice. And this is asking you to get 4 things. Okay. All right, the bottom one, Mason was probability of getting not a 3. Jesse was probability of getting not a 4. And Jalen was probability of getting a 1. All right, anybody? 11.6. Anybody need more time to write? Okay. All right. This one we're not going to draw a diagram. We're just going to talk about the probability. So probability of red, don't say it out loud yet. Probability of yellow and probability of blue. Don't say anything out loud yet. All right, what do you observe about red, yellow, and blue? Anybody? They're all equal. That's a great observation. They're all equal. And how many slices are there? 3. So how many slices is red? 1 out of 3. Okay, I know that's 33%, but it's also 33.3 repeating. So it's much better to use a fraction. All right, yellow is what? 1/3, and blue is 1/3. They're all the same. Okay. All right, so Jacob, what's the probability of getting a red? Yep. And this means the probability of getting a red on your first spin and then the probability of getting a blue on your second. So the probability of blue is 1/3, and you multiply those. 11.1. Okay. All right, Kendra, probability of getting a yellow? 1/3. Dan, I'm going to put you on the spot here. What's the probability of getting not red? Very good. 2 out of 3. Okay. Anybody? Okay. All right. Again, don't say anything out loud yet. We're going to do the probability of purple, probability of yellow, and probability of green. Give people a minute to write. Don't say it out loud yet. Okay, let's start with green. That's the easiest. Green is 1/2. Green is 1/2. Okay. Green is 1/2. What's the best way to figure out purple and yellow? Okay, where are you getting the 6 from?
Well, I mean, it also helps with the little arrow thing and breaks the half up.
Yeah, so I think that's the easiest thing to do is kind of make them equal slices. So divide your pie into equal slices. I think that's the easiest way to get it right. So how many slices are there that are equal? 6. There's 6 equal slices here. So for example, I'll prove my point with green. How many slices is green? 3 out of how many? Is 3 out of 6 the same thing as half? Okay. So purple is how many slices? 1 out of how many? 6. So purple is 1/6. I think that's the easiest way. Now yellow is how many slices? 2 out of, and that one reduces 1/3. You can do in your calculator, you can do 2 divided by 6, math, enter, and it'll reduce it for you. Okay. All right, probability of purple and then yellow. Eden, help me with this one. Good. Very good. And bless you. Ashley, what's the probability of green? 1/2. What's the probability of not purple? Anybody? 5/6. So look, purple is 1 slice out of 6. So how many slices are not purple? 5 out of 6. Okay. Anybody got this one? Okay, so in this scenario, one event does affect the other. So it's the probability of A. We're still multiplying, but it's the probability of B after A has occurred, since A will affect B. Okay? Once again, that'll make more sense when we actually do a problem. All right, so the host of a game show is drawing chips from a bag to determine the prizes for which contestants will play. Of the 10 chips in the bag, 6 show television, 3 show vacation, and 1 shows car. If the host draws the chips at random and does not replace them, find each probability. Okay, please underline does not replace them, because that's the game changer right there. Okay? All right, so what's the probability of drawing a vacation chip? How many vacation chips are there? 3. How many total chips are there? 10. Okay. Now, we're multiplying, but this is where you need to pay attention, right here. Okay? Right here. Then, to get a C, how many chips show car? 1. But he didn't replace the first chip. So, we started off, there were 10 chips in the bag, but now there's only 9 chips. Okay? And that's it. All right. So, what is this one? Good. Okay. All right. Jacob, what is the probability of pulling a television chip? Good. 6 out of 10. I'm multiplying. Now, again, you just have to think. If I've already pulled 1 television chip out and I did not replace it, how many you got? 5 chips left. Yep, there's 5 television chips left. And how many chips are left in the bag? 9. All right, this next one is not very clear. Probability of C. What do you think C stands for? Car. Then A. Do any of them start with an A? No. This one is 0. And again, that will be more clear on a test or quiz because it's just not very clear. So I apologize for that. Okay. Oh, sorry. What was this one? 33.3. Okay. All right. B. 3 cards are drawn from a standard deck of cards without replacement. Find each probability. So, without replacement is what I would underline on my quiz or test because that's the game changer. Without replacement. Okay? For those of you who don't know about a deck of cards, it's up here. All right. What's the probability of getting a diamond? How many diamonds are there? 13. You could count them up if you didn't know that on the board. Right here, there's diamonds. There's 13 cards. How many total cards are there? 52. Okay? And then I'm going to multiply. Jasmine, how many clubs are there? 13 out of 52. Oh, nope, sorry. 51, thank you. Because you didn't replace the first one. So instead of being 52 cards in the deck, we're down to 51. Okay? Now, this one, I need another diamond. I already drew a diamond, so instead of being 13 diamonds like there were to start with, now there's only 12 diamonds. And how many are in the deck? 50. Okay. All right. And what is that one? 1.5? Okay. All right, Austin C., what's the probability of getting a heart the first time? Good. All right, Rudy, what's the probability of getting a heart the next time if I didn't replace the first one? Very good. And Mason, what's the probability of getting a heart the third time? Good. Anybody? Yeah. quickly. Carter, read about Yana, please. Good. Ethan, what do I want you to underline? No replacement. Very good. So Kendra, what is the probability that he will first select a blue pen? That's fine. Take a minute and do it. 7/12, and then I'm multiplying. Sterling, what's the probability that then you get a black pen? Good. 3/11, because you didn't replace it, so the total number is dropping. And Jonathan, what about then a red pen? Good. All right, what you got for this one? 3.2. All right. A black die and a white die are rolled. What is the probability that a 3 shows on the black die and a 5 shows on the white die? Does the black die have anything to do with the white die? No, okay? Jalen, what's the probability of getting a 3 on the black die? Good, 1/6. And I multiply. Denise, what's the probability of getting a 5 on the white die? Good. So I'd multiply those. I think that one rounds to 2.8. Okay. C, Tammy, Sonia, Michael, and Roger are the 4 candidates for student council president. If their names are placed in random order on the ballot, what is the probability that Michael's name will be first on the ballot, followed by Sonia's name second? AJ, what's the probability that Michael's name will be first? Very good, because there's only one Michael, and how many total people are there? 4, okay? Now, Autumn, we want Sonia's name to be second. How many people are named Sonia? 1, so I've only got one choice on top. But Autumn, how many people are left? 3, very good. There's only 3 people left because who already went? Michael already went, so there's only 3 people left. All right, so what is this one? Okay. All right, Rudy, read Joe. Because I see you zoning out on me. Here you go. Read the first sentence. Huh? All right, we'll stay after you can talk about with me. Jesse, read D. It just means one after another. All right, Carter, what do I want you to underline? Not replace. Very good. Austin C, what's the probability of selecting a $10 bill first? Very good. So he added 3, 4, and 2 to get 9. Okay. Eden, what's the probability of then getting a 5? Very good. Because they were not replaced. And Jalen, what's the probability of getting a $1 bill last? Very good. What is it? Okay. All right, and Jonathan, read the last one for us. Good. Sterling, what do I want you to underline? He puts it back. And it's asking one of each. So let's start with to get a green one. So Ethan, what would be the probability that he gets a green? Good. And we're going to times that by Jesse. What's probability he gets a yellow? Well, it's 8 over 14 because why? He put it back. So the bottom number stays. Okay. All right, what do y'all have for this one?